So, hi everybody, my name is Amir Preminger, also known as Jumbo. I have here with me Sharon with all the cables, sorry for that. Probably some of you heard our noise plugging in. Now Sharon is just setting everything up. So we're from Team82, we're actually doing the threat research lab within Claroty. Our main sole purpose is to actually get paid to find vulnerabilities on critical infrastructure devices. What we're going to show you today is one of our research topics focusing on healthcare. We do research on XIoT devices, on any given device that might connect into your network, ranging from, of course, patient monitor, as you're going to see today, and going all the way to intercoms, which is one of our favorite devices in the network. Just see that the clicker works. We need the presentation on screen. Okay, so I'm gonna rush into it because we don't have a lot of time. We've only got 25 minutes, so we're gonna show it. So when the slide deck are gonna actually be up. Perfect, this is our playground. I said we're hacking everything. I have the luxury of actually buying and having a budget to buy everything. I know that a lot of our customers want to have a lab. So guys, if anyone wants to play with devices, you're more than welcome to play with ours. We have everything going from OT, DCS devices, HMIs, IOMT, patient monitors, you can see here, infusion pumps and IoT devices, intercom, as you can see on the right, cameras, and you name it. What we want to focus again today, I think we just heard a very interesting talk about healthcare. The FBI supports the fact that healthcare is one of the most targeted verticals within the critical infrastructure. They're the most targeted and attacked vertical, as we can see in the report itself, and that's why we decided as a threat research group to actually focus on that and show all the different attack scenarios that we can actually do on healthcare, focusing on embedded devices. The reason why we decided to actually focus on embedded devices is because taking into account the COVID task force report, which Josh actually led, and I think it's one of the interesting pieces because it actually shows the connection between CPS, cyber physical systems, into cyber attack. All of us are aware of the fact that ransomware actually can attack IT, and I think the COVID task force was actually showing the connection between attacking IT and how it actually influences the healthcare systems. Okay, but what they focused about is mainly what everybody is trivial and understanding is that digital records, such as patient records and other supportive system where everything is being stored, is the classical target. What we are expecting to see with all the vulnerabilities in healthcare is that the next targets are actually going to be the embedded devices. And what we wanted to show is the effect of what might happen if somebody's gonna attack the embedded devices, which are much harder to actually recover from. So we looked at the surrounding systems that are actually surrounding an ICU bed. And one of the main things that we wanted to focus on is actually the patient monitor. In this case, we actually decided to take a given patient monitor, which Sharon is going to talk about, how we actually disassembled it and find the vulnerability, and show how we can actually exploit it. The reason, again, why we took it, first of all, trivial. That's one of the basic components that you're going to see by an ICU bed. It reads a lot of the information about the patient, its status, BP, oxygen levels, and others. Everything is IP-enabled. Almost a lot of the patient monitors are actually connected into a main monitoring screen, connecting into the main system. Therefore, for us, it's accessible as attackers. We can do it remotely. We love to do everything remotely, and all the setup here is actually wireless. And of course, once we are able to actually falsify it or brick it, we're going to actually influence directly the customer care because the doctors will not be able to read the right metric of the patient itself. So I'm going to pass it to Sharon to actually explain a bit.
Yeah, thank you very much, Jumbo. So hi everyone, I'm Sharon. I was given, actually my team was given a task a few months ago to get a patient monitor and understand the attack vectors on it. So the first thing we did is to purchase one. And it turns out it's very easy to purchase a patient monitor and actually everything from PLCs to healthcare devices. So we purchased one on eBay. We got this and we needed to understand what to do with it. So the first thing we did is we powered it up and tried to understand how to use it. So we started to read manuals and we started to understand how nurses and doctors are actually using this. And we even tried to teach ourselves how to do ECG. As you can see, I'm all hooked up to different cables because we now I hopefully know that we do know how to do ECG. So we wanted to research the attack vectors on it and to get some interesting results. One of the interesting results that could be is to actually attack the device and get a shell on it. So what we did is we tried to understand the hardware components of it, and we started to break, not actually break, but disassemble the device from the hardware perspective. And what we did is we actually were looking for the firmware software of this device because we could not locate it online anywhere. So what we did is we tried to search for where the specific chip of the firmware, the flash, is located on the PCB. And as you can see here, we had some exploration phase where we tried to understand where is it. And finally, we mapped all the different chips on the PCB. So we started to take each component, each chip, and Google the identification of this chip. For example, this was the flash chip. We just took the identification number on it, Googled it up, and we found the vendor's selling point of this chip. Now we knew that this is the flash, and we wanted to extract the firmware from this flash.
That's usually when we stop and actually wait for approval, because this is the point where Sharon might break the device, and then I need to go and buy another one. Okay, so we're good in purchasing, but buying more and more, our CFO would not like that.
Yeah, so the reason why sometimes we break the device while we're doing this is because we actually needed to extract the chip. We actually needed to hit all of its legs in order to extract it physically. As you can see here, we even used Kapton tape in order to protect the surrounding components. So what we did, we heated all the legs, we extracted the chip itself with the firmware, and now we had the chip. We used microscope to make sure that all the legs are in good shape and all the different components are okay. And luckily, we did not break the device. Sorry, boss, not this time. And we used the external chip reader to read the firmware. Now, we were not successful the first time to read the firmware, but on the third or fourth time, we were able to actually read all the bits from the chip and extract the firmware itself. Now we had a huge blob of the firmware, and we want to understand if it's really the firmware of the device. To do that, we search for some kind of guiding strings. For example, the name of the company that produces this device, or other peripherals, such as SPO2, that are related to the sensors of this device. So once we confirmed this, we started to work on the firmware itself. So we wanted to reverse engineer the firmware in order to understand if there are such vulnerabilities that will allow us to exploit them and actually get our hands into the device itself, or in other words, get a shell. So we plugged in the firmware into IDA, a reverse engineering tool, and we started to look on all the different functions of the device. Luckily, we found a vulnerability and we were able to exploit it, and we got our shell on the device. It was very fun because it's the first time that we're able to execute code on the device, and now we could leverage this and move forward to do some kind of a more sophisticated attack. For example, one sophisticated attack that an attacker can do with a medical device, and specifically a patient monitor, is to fake vitals. So just to sum up quickly what we did from when we purchased the device up until this point, we bought a device, we had a physical device in our hands, we wanted to get the firmware, we could not get the firmware online, so we hacked it, we extracted the firmware from the flash, found the vulnerability, exploited the device, and got a shell. Now the question is, can we alter vital signs on the device?
So I'm going to let Sharon actually plug in. There's going to be a demo, so I'm just buying time. So as Sharon has been plugging in, and you're going to start hearing some sound coming from the patient monitor. Everything here is real, so sorry if we're going to get a blue screen at some point. So our main purpose was actually faking vital signs, because everybody understands we're going to show how we can brick the device. Sharon almost did it himself when he desoldered it. But what our main goal was actually understanding how we can take this patient monitor, actually make it change all the values that it was reading from the sensor themselves and actually present our own customized value depending on which attack we want to do. Just a disclaimer, I'm not a doctor, okay? I don't know much about the values themselves, but I know a bit about how we can actually alter data when we actually able to gain access into the patient monitor. So in a nutshell, what we actually have, like in any other CPS, cyber physical systems, we have a sensor. In this case, we can talk about the SpO2, the saturation, that reads data using a sensor, some physics. Somebody came up with a way to actually read it. A software piece is actually interconnecting and talking to that sensor, getting the data. That data is being normalized in order to show it in a given range, and that's being actually shown on the screen itself. Okay, this is the normal reading process where we were able to get the value themselves. What we wanted to do is to actually intervene in the middle, actually find a way that when a sensor is reading some sort of a value, we can customize it and put our own value. The example here is 0, but could have been easily any given other number. Again, I'm not a doctor. I don't know what I need to put here in order to make somebody scared and shove a needle into a patient. But I'm sure that we can find out with a doctor that they have their own procedures, okay, based on that. When that data is being read by the code, I actually inject the code into that patient monitor logic, and then I can actually control about what's going to be presented on screen. Okay, everything that I just showed you here, it's something that Sharon is going to show how using the vulnerability we found on the patient monitor, we're actually able to achieve. So I think we're now ready to pass. Can we switch to the PC?
And also, if we can get the mic working.
Yeah, it works. Okay. You can hear the bips, right? Okay, so we just plugged it in my hotel room when we brought it in. I'm here with my wife, and she said you can't keep it in the room. Please throw it out. So
so I'm going to explain a little bit about the setup that we have here. As you can see, I'm all hooked up. So what we have here is the patient monitor. We already hacked it, so it runs kind of a customized backdoor that we created just for it. Not only we created a backdoor, we also created an iPhone app to control it. So this is the iPhone app. You can see it on the screen. You can see that if I'm moving this, it's mirroring on the screen. And this is a completely working iPhone app that controls a customized backdoor running on the patient monitor. As you can see now, the mode that the device is running is normal. You can see it because the button kind of flickers.
And you can see that he's nervous, okay? Everything here is reading correct, okay? Everything is real. We were very nervous that he will not be nervous, so good work, Sharon.
So that's an interesting point, because you're saying that I'm nervous. You know what? I'm gonna jump a bit to raise my heartbeat. Let's see if it's moving up. The one.
Don't faint. I'm not a doctor, okay?
Okay. So I was about to discuss a little bit about the setup, but he thinks I'm nervous. I don't think so. Let's see if I can change the monitor such it will say that I'm not nervous. So let's see if we can modify it to make sure it looks like I'm not nervous at all. Okay, now I'm nervous because that's the demo part. Oh yeah, all the signs look normal, Jumbo.
So no blue screen, thank God, and Sharon just relaxed. Okay, I think we just found the cure to just calming down people. We just need to sell them that app, just like you sell TVs in hospitals. So I think, Sharon, if we can explain a bit about what we're seeing on the screen.
So to be honest, I am nervous. Let's switch to a normal mode, and I'm going to discuss the setup itself. I think my heart rate is like beeping. And let's see what's the heart rate? Yeah, it's more than the fake data that we inserted. So okay, we have the patient monitor. We have our customized backdoor. We have the application that controls it, and we also have what you see on the matrix style green text on the screen. This is the CNC server. So the application, the app that we built, is talking to the CNC, and the CNC and the patient monitor, the backdoor, is collecting payloads from the CNC. So we can actually control whatever you want on the patient monitor. through the application that communicates with the CNC. So one of the attack vectors that we thought would be interesting to show is what if we want to ransomware the device. And we actually prepared such a scenario. All I need to do is to click on the ransomware button. And hopefully it's going to work. So the backdoor needs to pull the payload from the CNC. Let's see. Something is going on here. Hopefully it's going to work.
Something needs to die. I think that's one of the most. Okay, now.
Yeah, now we have a ransomware on the device.
I think it's going to be the first time ever you saw on stage how the speaker is actually feeling, and then he cannot fake it. So you can see when he pressed the button, and he got a bit.
Yeah, everything pops up. So right now the ransomware is running on the device, but as you can see, the vital signs are still moving. If it's a ransomware, if it's a real ransomware, we don't want to show vital signs at all. We want to stop the device. So let's do that. And it's gone.
So I think what the main goal for us, again, as we wanted to emphasize, taking into account the COVID task force, what we're showing here in the demo is the fact that if you think about it, attacking IT infrastructures, there's a lot of people in the room that are going to say data recovery, and there are IR team and IR companies here that also can help. One of the main goals for us when we started looking at the threat landscape of ransomware for medical devices is how long it's going to take to actually remediate such an attack. In this example, Sharon was able to, as you can see, do whatever he wants on screen, up to the limitation of actually doing more text writing. But if I would give him more time on that patient monitor, it can even make you coffee. Okay, so the question is, what we wanted to show is if you think about the fact that what's unique about CPS system versus IT networks is that if we brick those patient monitors, getting a hand on new ones, as we have seen in COVID, in other medical equipment, it's not as easy. Okay, so one of our goals was to actually understand what's going to be the impact and how long it's going to take us to actually get ability to actually break the devices that it will not be recoverable. And I think Sharon showed you enough that it is doable. And I can tell you that the timeline that it took us in order to get into this phase is actually 2 weeks. Okay, it's something, again, it's a dedicated device. Since the point that Sharon actually looked and ordered it from eBay, which the longest it took us is actually getting the device to Israel, because Justin needed to bring it. And up until we were able to actually totally run a backdoor on it and get to the point that we can totally control it, it took us 2 weeks. So the takeout from this talk that we wanted to take is that, again, protecting IT infrastructure is critical. Okay, we know how to do data recovery, we know how to protect IT, but the embedded devices themselves, the medical devices, is as important as the IT system in order to recover them. There are other ways to actually protect. Again, patching, as we heard, there's a lot of problems with unpatched software and end-of-life software, but there's other compensating controls that can be introduced in order to make them more secure. I hope you enjoyed the demo. And it's going to take us a bit to take it off stage. But if you have any more questions, you're more than welcome to come to our booth. It's on the right.
Yeah, so I just unplugged everything.